Hello and welcome to the final session of the Permafrost Day at the Chrysler Pavilion at COP28. My name is Gustav Hegelius. I'm from Stockholm University in Sweden. And in this last presentation, or in this last session, I'll be presenting the Arctic Permafrost Atlas. So this Permafrost Atlas is a collaborative work, but it's mainly been led by GRID-Arendal in Norway, and the lead cartographer has been Levi Westervelt, and he's been working together with Tina Schulmeister, as well as Hyglant V and many others from the Nunataryuk Research Consortium. And I'll be presenting the atlas on behalf of that research consortium, where I was one of the many members working on this atlas and contributing to it over the years. So the atlas it's a physical book. It's a physical atlas that has been printed. The first edition has already run out, but the second edition will be printed to follow that up. But it's also available as an online resource. So if you Google the Arctic Permafrost Atlas, your very first hit will be the GRID-Arendal webpage, where you can actually find the PDF and other materials. The PDF and the printed book consists of in total 156 pages. So it's a massive piece of work divided into 7 different chapters. In total, there's 82 different maps and graphics that have been produced specifically for this atlas based on a range of different scientific data available and scientific knowledge. It contains roughly 50,000 words, so there's quite a lot of text and information in the atlas. It also has 9 different portraits of individuals either living in the permafrost region or working on permafrost. So it's portraits on permafrost scientists, portraits on indigenous community members living in the permafrost region, and of local members of communities in the far north. In total, in producing this atlas over time, there's been 155 contributors. Most of those contributors are scientists working on permafrost, ranging from physical scientists to social scientists to economists to political scientists, and also a large number of cartographers or experts in visual communication, copy editors, scientific writers, etc. It's been a large team effort to produce this. So the Permafrost Atlas has been produced over the last 6 years. So we've had 6 years of Nunataryuk, which is a research project that was funded under the European Horizon 2020 research effort. And throughout this project, we've been working on the atlas. So I want to show some slides of this process and how it's been going. In one of the very first Nunataryuk meetings in 2018, there was an early career researcher workshop where the PhDs and postdocs of the Nunataryuk Consortium gathered, brainstorming on what type of maps and visuals and information is interesting to have in a permafrost atlas. This is one example of the brainstormed hand-drawn graphics that was shown at that time. This particular example shows the distribution of mercury within the global system, where most of the global mercury is actually stored in permafrost, which is one of the interesting graphics that you can learn more about in the atlas. But this was just a starting point, and we had early career research workshop. We had the senior researchers being more involved, coming with suggestions, also reaching out to people outside of the Nunataryuk research community, other permafrost experts, bringing them on board and asking them what type of data they would want to showcase. The very first draft, the idea was to have something around 120 pages. This shows a circle graph of the context. The idea was to have roughly 30 pages of maps, 40 pages of text, you see here, 10 pages of infographics and portraits. Now, in the end, as I showed you a while back, we actually landed on over 80 pages of maps and infographics. So the atlas grew and grew, and more material became available and was included in the atlas. Now, during the Nunataryuk project, we worked on this atlas in parallel to the other research that was going on in that project. So the atlas was one of the products that we're doing. It's an outreach tool to communicate about permafrost to the general public. But of course, in the middle of the project, COVID came around, so we didn't have any physical meetings for quite some time. But that didn't stop the team at GRID-Arendal and the coordinators from the Alfred Wegener Institute on working on the atlas. So this is just a screen dump of an interactive online session that we had with the consortium on one of our meetings, looking at different aspects and chapters of the atlas, and people being able to give online feedback to the progress or to the work in progress that was being produced. In May, COVID had ramped down and we were able to meet physically again. And by that time, the team from GRID-Arendal, led by Levi and Tina and others, they had printed early versions of a lot of the maps and graphics. And we had an exhibition with all of the scientists at the General Assembly meeting of Nunataryuk, and we walked around and gave feedback and comments on the maps, on the facts, what things could be added, what things might not have been, highlighted correctly, if there were factual errors, etc., etc. So that we had a lot of this iterative back and forth on the different graphics and the facts included in the atlas. And then the final product ends up being a large amount of very nice and very informative graphics and maps. I'll just show you a few examples now before moving on to showing you just some photographs of the final release. This is one example of a map included to the atlas. It's a map that shows the distribution of permafrost in the Northern Hemisphere, including both on land and subsea. And the coloring in green for land and blue for the subsea permafrost shows the estimated amount of carbon stored in the permafrost system. And you also have other contours of, for instance, the Jedoma extent, which is a specific type of ice-rich and carbon-rich vulnerable permafrost across the Northern Hemisphere. So in this example, scientific data sets or databases from different sources were pulled together to make this map and to really pull all of it together. Another example of a map that I think is really fantastic shows the planetary perspective of the distribution of permafrost. So in this case, you see a map projection that is not what you're used to seeing, but you do actually see the full extent of the Earth in this map, and the extent of permafrost found in the Arctic that is dominating. But you also see the large extent of permafrost in the Tibetan Plateau, and you also see permafrost in high mountain areas, including in South America, and on the Antarctic continent, where ice-free exposed land surfaces also contain permafrost. So the atlas is not only maps. It is an atlas. So I think the core of the atlas is the maps and the infographics, but there's also a lot of I would say art within the atlas. There's fantastic photographs. There's also other works of art by indigenous artists and others, and there's also a lot of portraits of individuals, as I mentioned before. So this shows just one example of an individual standing in a permafrost freezer. You see, this is actually a hole dug into the permafrost used to store meat to keep it over the summer months in the sub-zero temperatures within the permafrost. Another example is a spread that explains or gives information about permafrost thaw occurring in this case a community in North America, including fantastic photographs of the inhabitants of that area. And then the next spread contains more information and in-depth portraits of what is happening in this community. There are also portraits, in this case, of an artist working on to sort of communicate permafrost and the effects of permafrost thaw on indigenous communities and the Arctic in other ways than through maps. So there's portrait and information about this. And also other types of infographics or sort of attempts to tie the whole thing together. In this case, this is a spread that ties together. One shows the big picture of the threats or the hazards, the risks associated to permafrost thaw around the Arctic. Then combining a lot of the science that was produced in the Nunataryuk Project around this. You have physical processes on the left that arise from climate change impacts and interactions with permafrost that then lead on to key hazards that are outlined and the consequences of these hazards for communities, local and indigenous, and on the far right, a summary of some of the actions needed to alleviate these hazards and negative consequences of climate impacts on permafrost. So in the middle of 2022, after a lot of back and forth with the scientists in Nunataryuk, you see actually on the background there, you see these boards that we've been working on, where we have put up a lot of post-it notes to give feedback. Levi and the team at GRID-Arendal, they had a first draft of the atlas ready, and here you actually see the external advisory committee of a group of skilled, internationally renowned artists and cartographers that helped to give feedback on the atlas, also with a few scientists from the Nunataryuk consortium in the meeting, doing sort of the final polishing and editing of the atlas. And just some examples of how the iterative process of how this map's developed. This is one of the first drafts of a map of permafrost in the Arctic, and then after some feedback and polishing, because it was refined and changed for this map, which gives less information on settlements, etc., but that gives a much stronger sense of where the permafrost is actually present. So the hatching has been changed, the color scheme has been changed. There's the communities are taking less space and attention in the map, etc. And this shows you the very final spread that was included in the printed atlas, where the color scheme has changed to an orange instead of the dark brown, which didn't come out as well in the printed format. And then in May 2023, first test printing, some copy editing, and final error fixing in the text. And then this is the front cover of the final product, the Arctic Permafrost Atlas, which was actually launched at the Arctic Circle meeting, including, here you see some example of the final printed atlas, with also some sort of big picture fold-outs that were included with the printed atlas and handed out to participants of the Arctic Circle meeting. The Permafrost Atlas is also associated with a photo exhibit called Permafrost Matters, which you can also find on the same website from GRID-Arendal if you Google the Arctic Permafrost Atlas. And this was displayed for the first time at the Arctic Circle meeting. You see some examples of it in the background here, and we actually have some of that exhibit printed on posters here at COP28. So it's in the hallway outside. Some of it is in here in the room with us, and it was also presented at Arctic Circle with quite a lot of interaction with media and policymakers at that event. And so this is what we had to share with you on the Arctic Permafrost Atlas. Any contact if you want to have questions or you're interested to learn more about the atlas, you can find my email on here. And the team from GRID-Arendal has also prepared a short survey, and where you can also find more information using this QR code that's on the final slide here. Okay, I'd say thank you. So are there any questions or comments?
Sorry for coming late. I represent GRID-Arendal. I just want to say congratulations on the atlas. It's fantastic. It is fantastic. It is fantastic. Sorry.
Yes.
It's on the wall.
Yeah, some of the visuals are here, and the second printing is, I think, it will be printed in a second edition with hardback. I think so. It should be possible to do.
And I represent Central region.
Yes.
We also have a lot of permafrost.
Yes.
Any activities there, ongoing activities, or?
Do you mean research activities broadly?
Mapping activities?
I mean, yes, there is quite a lot of. So the atlas does contain. Now I didn't show all of the spreads. Obviously, it was just a small selection. So I mean, we do have spread material on all of the permafrost extent across the world, including Central Asia, which we don't find here. But there are also more in-depth information on other regions in the atlas than just this spread. I just chose this because this was chosen as an overview. But there is quite a lot of permafrost research going on in Central Asia.
In Central Asia?
In my own work, I do collaborate a little bit with Chinese researchers working in the Qinghai Tibetan Plateau, and Sebastian Westermann, one of the contributors to this map, also works a lot in Mongolia, for instance. But there's quite a lot of collaborations between European and Central Asian researchers.
No post-Soviet companies where you collaborate with people?
We have had a lot of collaborations with Russia, but those have been frozen due to the war in Ukraine.
Is not online, or?
It is. So if you Google the Permafrost Atlas, the very first hit you'll get is GRID-Arendal webpage of this atlas, and there's a PDF with all of the atlas and the exhibits as well.
And you also have a data set, underlying data set.
So all of the data, or yeah, I would say all of the data is available in different repositories, but it is not gathered. So you would find the references in the atlas. It's actually the information is there. And like, for instance, this map is globally published. This is part of this month. This specific map is from the European Space Agency project, where it's all openly published. The carbon maps are openly published, etc. So the data and the population database that we see an example of over there is also openly published. So the data is in general available, but there's no, with the exception of the actual maps that you can just download as PDF, there's no central repository for all of the data. That's also because it's almost 100 different maps, and a lot of different institutions have been involved in making these maps. So we've been the cartographers or the scientists making the atlas access the original data, but for proprietary purposes, we would not be able to just take other institutions' data sets and host them all in one place. You could make what we call a metadata database with links, and I think that's being discussed whether we would be able to pull together all of the links to all of the data sets so that users can easily find the relevant data that was used as input to the atlas. And I think that is underway, but at least it's not online yet.
Yeah, I think it's a kind of process like model process atlas for the modeling.
Yes.
It's not curiosity like I can see the what region what the different colors represents like it's like different like extent of permafrost or is there like a kind of regions or about the different colors.
Yeah, so the different colors in this particular map, for instance, shows the percentage coverage or the extent of permafrost in that area. So whether it's more than 90% or between 50 and 90, then it's usually called continuous or discontinuous permafrost. But if you really zoom in at the very fine level, this map is available at a 1 kilometer resolution for the whole world, and then it's what the individual pixel would show is the probability that there is permafrost in that pixel, expressed as a percentage. But if you zoom out, that becomes equal to approximate permafrost coverage in percent over a slightly larger area. No, so this is something else. So this actually shows, the coloring shows the extent of permafrost, but the green color shows how much carbon is stored in the permafrost. Because one of the key aspects of why we are studying permafrost is there's so much carbon, old plant remains that's frozen in the permafrost, and when they thaw, it's exposed to decomposition by microbes that create methane and CO2. And the more carbon there is, the higher greenhouse gas fluxes you get. So the green colors is carbon frozen in soils on land, and the blue colors is carbon stored in subsea permafrost. Because there's also permafrost below the ocean in the shallow shelf seas. And that's because during the last ice age, so much of the water on land was tied up in the ice sheets. You had massive ice sheets covering most of North America and Scandinavia, and that drew down the sea level about 120 meters, which meant that all of this blue stuff here was exposed tundra. So you had mammoths and bison roaming like on flat tundra in that area, and permafrost formed. A lot of carbon was frozen in the soil, and then when the ice sheets melted, the seas rose, and now the seawater is covering subsea permafrost. That is also potentially emitting methane, or that is emitting methane to the atmosphere.
I came a little late. I was since late. I missed this part of the conversation, but I was in Alaska this year, and they have a permafrost problem, and that it's melting. And I'm interested in trees, and they had phenomenal tree mortality. There's hundreds of miles of dead trees, and I was wondering what effect does permafrost melting and subsequent methane production have on trees? Does it displace oxygen in the soil and harm the trees? Have you seen a trend like that?
So I mean, thawing of permafrost, which is forested, would lead to destabilization of the ground, and you have something which is called a drunken forest, which is the way the forest looks after the permafrost thaws, because they the tree start to tilt in every which direction, and which would lead to tree mortality. There might also be other reasons for the tree mortality in Alaska, including insect attacks, fires, and drought. Actually, also causes quite a lot of tree mortality. But the permafrost thaw would usually lead to initial dieback of those trees, because in Alaska, for instance, or in North America, you have tree species that are well adapted to living on permafrost, black spruce and white spruce, and they grow quite well on permafrost. And then when it thaws, the ground subsides and changes, and then the forest would probably die, and then it would, over a long time, that area might be recolonized by by a new forest growing up again, but that would take quite some time. I'm not sure about. Did you ask whether there was a link between the methane release and the mortality of the forest?
Well, so trees rely on oxygen in the soil to respirate. So if that's displaced by methane, it could possibly poison. It's like a gas leak.
Yeah. And I think also just the fact that the permafrost thaw leads to subsurface changes in the soil, it usually becomes wetter, and then when the water comes in, the oxygen, the trees would actually be they would be oxygen deprived just from the water flooding them, basically. So you don't necessarily need the methane to do that job; the water will do it for you. Yeah. So trees would basically drown after permafrost thaw, and you see a lot of that in Siberia as well after fires. Yeah, after fires or large permafrost events. You get what we call thermokarst, where the whole ground subsides and you can get really wet areas, and then the forest would die back quite quickly.
Is there a lot of people in Siberia?
It's driven by permafrost. The main reason for tree biomass loss in Siberia is fires, but also permafrost. But at the same time, when it gets warmer, the tree line does also migrate northwards. So in some places, trees are growing and perhaps migrating northwards. In other places, they are dying. So it's a complex mosaic of dynamics. But then the net effect is, especially if you include the fire trends we've had in recent years, might actually be a reduction in forest biomass, at least following these very massive fire years we've had in Canada and Siberia in the last 3 or 4 or 5 years.
Yeah, so how did a bunch of scientists come up with the idea to do something so creative?
That's a good question. Scientists aren't typically that creative. No, it's Nunataryuk, the project that funded this from the very beginning. One of the outreach products that we sort of wrote in the proposal that we would deliver was we wanted to do something a little bit more substantive. That was not just about the project, but that was really wider. And I think it was Tina at GRID-Arendal and Hugh, the coordinator, Hugh Landry, and Avi, the coordinator of the project, together with Lena and Paul and others, that really discussed back and forth and came up with this idea of an atlas, something that would have longevity, and really much of the outreach budgets of this project went into the atlas. And at the end of the day, I think it was a good call. I think the final product is really nice, and I think it will last for a long time. And hopefully, perhaps we will get down the line there might be funding to update it or have a second release of it. But there, as you mentioned, there was no global permafrost atlas before this. There have been other releases of like a northern soil atlas and some other, but nothing that takes also everything from the physical environment to the people living there to this populations and to the effects of climate change. I think it's a really nice product.
Is there any permafrost at all in the southern hemisphere?
Yes, there definitely is. So this is actually a graph that shows. So this map shows the whole world from a different perspective. So here you see and then coming into South America. So there's permafrost in the Andes, and in Antarctica, the exposed land areas of Antarctica that are not covered by the ice sheets experience, or they also have permafrost in them. But of course, the vast majority of permafrost is found in the Arctic and then the Tibetan Plateau. Yeah.
So how do you see this thing going?
The permafrost?
Yeah.
It's thawing rather rapidly. So for every degree of global warming, we lose about 4 million square kilometers of permafrost.
And what does that compare to the total permafrost?
So all global permafrost is about 16 or 17 million square kilometers.
16 or 17?
Yeah, something like that. I'm not sure.
4 million already?
For 1 degree of global warming, we'll lose 4 million. Yeah, so some of that is already lost. Some of it is, but it's also, it takes a little. There's a lag to it. Permafrost responds very slowly to warming, so it's inevitable, but it's quite slow. So we still haven't seen. I would say we still haven't seen half of the permafrost loss that we're already committed to. If we would somehow magically cap warming at 1.2 where we are today, permafrost would still keep thawing and emitting CO2 and methane for a very long time. It takes a very long time because it's such a massive system and there's so much inertia in it. It takes a long time for it to come in equilibrium with the climate. We can even still see remnants of a lot of the permafrost, for instance, if we think of northern Scandinavia. I'm from Sweden. In northern Sweden, we do have permafrost. But all of that permafrost formed during what we call the Little Ice Age, which was a cold period a couple of hundred years ago. And during Little Ice Age, which ended several hundred years ago, permafrost formed in northern Scandinavia, and it's still there. It's outside of its climate equilibrium, so even it's going to disappear. It's just that it's taking a long time. It's happening slowly. So a lot of the permafrost we have that we see on this map is already doomed. It's going to disappear regardless of what we do.
So your permafrost in Sweden is temporary, you know.
Yeah.
It's taken at least a couple of hundred years for that.
Yeah.
To start going out.
Yeah. To completely disappear at this. And the permafrost that reacts very slowly tends to be, we call it ecosystem protected. It's usually in peatlands. So you have these thick organic soils, which act as a perfect insulator that just preserves the cold permafrost. Peat is what we used to insulate houses. It's a very effective sort of way to keep the summer heat from penetrating into the ground. So you have the permafrost peatlands that have a core of ice, but it's not thawed yet, but it will. It's very like the permafrost is basically at 0 degrees, just below the threshold, and that's true for most of the southern boundary of permafrost. It's very warm and it's just at the threshold, and then one warm summer can be enough to just tip it over, and then you get this local collapse of ground that leads to infrastructure damage, ecosystem damage, and quite a lot of greenhouse gases.
And what's the upside?
The upside?
Yeah.
I don't think there is one. Not specifically to permafrost thaw. I don't really see an upside, unfortunately. I mean, there's people. There was at least some. You heard people say that, well, when it gets warmer, we'll get more forests. The Arctic will be easier to live and work in. But the harsh truth is that also the negative effects of infrastructure damage that we see from permafrost thaw, they are far outweigh the potential gains. So in many hundreds of years, perhaps it will have stabilized and the forest will grow better. But there's a long lag time, a long time of just more and more damage. Like half of the Russian oil and gas infrastructure is on permafrost that's vulnerable by 2050. So there will be a lot more collapse of infrastructure, gas, oil pipelines that will leak, airports and communities all around the Arctic where people are living. A lot more damage happening. I think we heard a number earlier today. Sue Natali from the Woodwell President, she mentioned something around $200 billion in just infrastructure damage alone by 2100.
Low scenario.
Yeah, that was the low scenario. The high scenario was over 300. Yeah.
Is there anything which can be done locally to prevent that, or is it sort of 50 times?
So very locally, you can do, like, there are engineering solutions to protecting infrastructure. For instance, the oil pipelines that are built through permafrost do already have some engineering solutions to keep the permafrost a little bit more stable. There's only so much you can do with that. It helps a little bit, but it's like if the climate envelope of the permafrost really goes way beyond, you can't really save it. Other sort of simpler solutions that you can implement is actually when you clear away snow in the winter. If you're super effective, and actually if you have a small community and you take all of the snow out of the community and put it outside where there's no infrastructure, the cold air will be able to penetrate into the ground, and you might actually save, because the snow makes a very big difference. So just by taking all of the snow away from the infrastructure and putting it somewhere else, you actually can save that permafrost underneath the community locally But that's that's a solution that is feasible only locally. But if you think of the millions of square kilometers, there's no geoengineering solution to permafrost thaw other than sucking CO2 out of the atmosphere. The only solution is limiting radiative forcing for the broader impacts. Yeah, sure.
Can we have like kind of estimate for the water reserve in permafrost, like how much water we can have permafrost? If we have like one big destroyed area of permafrost.
So do you mean how much ice is stored in it, or
in terms of water into that?
Oh, I'm not sure about the numbers. I know that ice also, because there's actually a lot of ice in the permafrost, and when that melts, you end up getting a higher discharge of water, fresh water into the Arctic Ocean. And you do see that as some of the results of that are decreased salinity and actually increased acidity of the Arctic Ocean as a result of that. But actually also sea level rise. So the permafrost does contribute to sea level rise. And I think the projections are that it might become equivalent to glaciers, so just not ice sheets, but glaciers. It has the potential for less than a meter, certainly less than a meter, but it does also contribute to sea level rise. I don't know the volume, unfortunately. I mean, one of the ways that we track changes to permafrost is using like the GRACE satellite mission. So the satellites that have been designed to actually study ice and water are also used to study changes in permafrost mass. So there are studies of that, and there's publications on it, but I don't know the numbers by heart in my head. But the changes in volume are large, certainly, because it's a massive area, but then it's also very deep. In Central Siberia, the permafrost is more than a kilometer deep, so the actual volume of permafrost is really, really large. If you can count the volume, it's probably the largest component of the biosphere.
Sure, you've already answered this question, but so when you mentioned the depth of the permafrost, does the top layer thawing attribute to the rest of the layer eventually thawing? Will that create a cascade?
Yeah, so it's a good question. So you have the permafrost layer is, in Central Siberia, it's deep, but when you go close to the margins, it's shallower and shallower. And then we have the very top, which is called the active layer, which thaws every summer, which is usually between 30-40 centimeters in the Arctic tundra down to a few meters if you go to the forested areas in Central Siberia. So this thaws every summer and refreezes in winter. And that's a natural process. And this is where all the plants have their roots, etc. So that's where life is sustained in the permafrost region. But then you have a gradual deepening. So this act is thawed a little bit deeper every year. And that leads to more and more heat being transported or convected into the permafrost. So there's a gradual loss of permafrost and warming of the near surface permafrost that happens. We call that gradual thaw, and that happens everywhere. And that is something that is affecting all of the permafrost right now. Even if it's only thawing a lot along the southern margins, the active layer deepening and the warming is happening everywhere. The warming rate of the permafrost itself is actually at highest up here. So here, the very cold permafrost has gone perhaps from being -7 to -8 quite quickly. So we're seeing heat is penetrating everywhere down to. And then you have other processes that might come from the side, like coastal erosion or along lakes and rivers, or when you have a lot of ice in the ground that we call abrupt thaw, and then you can actually get collapse of permafrost to several meters happening in just one summer or just a couple of years. And that's usually when you have a lot of water, or that's really effective at transporting energy into the permafrost, and the ice is disappearing and the ground starts slumping down, and then you get more water so it becomes like a local feedback mechanism that just accelerates. So we have those two, the gradual and the abrupt thaw is happening at the same time a little bit everywhere, and sort of working together to thaw the permafrost.
Are you able to put together numbers, what we can expect for methane exhaust from this?
Yeah, so the projections of permafrost emissions. So by the end of, like, if we keep going, if we look at a scenario of implemented policies right now, which would land us at 2.9 degrees warming by 2100. Following those projections, the permafrost will emit roughly as much as the EU does today per year at 2100. So the permafrost alone will emit equivalent to the whole EU emissions by 2100. It's going to start increasing slowly. By 2050, it will be significant, and then it really accelerates, and it keeps accelerating past 2100 into 2200 and 2300. So
So you're saying, or you're predicting it to have as much emissions as the EU has in itself?
yes, so per year, the EU emissions per year right now, those in the permafrost alone, without any help from humans except the warming we're doing, will emit that much by 2100. So annually by 2100, permafrost emissions will be roughly what EU emissions are today.
Is that reflected in any of the NDC?
No, it's not in the NDCs. It's partly included in the not fully, I would say, but partly included in the IPCC estimates of the remaining emission budgets to stay below 1.5 and 2 degrees. So that's why the last IPCC report was the first assessment report to really include the permafrost emissions in the carbon budgets in that way. So it's included in so they've accounted for those emissions in the carbon budgets, but it's not, I mean, really, if you when you're talking about NDCs, there should also be like the country of permafrost NDC should be at the table somehow, because these emissions are unavoidable. It's just a matter of how large they will be. But it's not necessarily in the global stocktake process.
Around the cooperation with Russia has stopped.
Yes, so a lot of it. I think that depends on different sort of national. So for instance, I'm Swedish. The advice or instructions that as a Swedish researcher working at a federal university that I got from in Sweden, we don't have any institutional collaborations with Russian institutions while the war is ongoing. So it's in the same way as collaborations in the Arctic Council was also frozen until Norway took over the chairmanship. So I was also science lead on the Arctic Council project that was immediately halted and frozen until further notice upon the invasion of Ukraine for the full-scale invasion. But it's different countries have different rules, so that's I think it varies. But in most European countries, the really really important long-term collaborations we built with Russian scientists over decades. There's a permafrost science originated in Russia. The first measurements, the first scientific descriptions, it's all from Russia. And there's very many really good permafrost scientists in Russia. But they are still working, of course. There's still measurements happening, etc. But there was an important Western contribution to that science as well. That's been paused now. Yeah.
So any suggestions as to what will be the way forward?
Emitting less CO2. It would be, I guess, the obvious answer is if you're thinking of the way forward for limiting damage to the permafrost system or for observing.
I mean, to stabilize it or something, or to.
I think that we see that there's really a large difference between, for instance, 2 degrees of global warming and 1.5. So I think that permafrost is one of the cryosphere elements that clearly tells us that 2 degrees is basically unacceptable. The amount of damage that will do to the permafrost system at 2 degrees is going to have long-term consequences. And I think down the line, even 1.5, if we can on a longer term keep going down from 1.5, that would also be very beneficial to the Earth system, I would say.
But if you make your projections, like you said, in this way, where you describe it as an unstoppable phenomenon, and you extrapolate your predictions into the future, what is the chance of us sequestering that much methane, or similar gases that will be?
I think that
regardless.
Yeah, I think that for us to reach the 1.5 degrees, certainly, and in most scenarios also the 2 degree target, those scenarios already include extensive implementation of negative emissions, whatever those solutions are. I think my expertise is I'm not the right person to ask what the best solutions are. So to reach 1.5, we have to have negative emissions after 2050 anyway. Permafrost will add even more need for negative emissions. It will also add a need to sustain those technologies or whatever is, because I think that the natural or sort of the ecosystem-based or the nature-based solutions that do also give us increased carbon storage in the biosphere, most of those sinks will saturate. So like we can alter land use in agriculture, planting forests, wetland restorations, all of those things help. but those sinks will saturate, and they will not be. We can't sustain those sinks at a high level for long enough to be a really long-term negative emission solution. So I think that they will need to be complemented with other solutions. If we have the need to offset, for instance, permafrost emissions for hundreds of years, even if restored wetlands, they are sustained carbon sinks, but probably not of that magnitude that they would be enough, right? So, and forest regrowth is most effective in the first 30 years, and then the effect of that also saturates. Same with agricultural soils. We can increase the carbon stock in agricultural soils by changing our land use patterns, but that will also saturate usually within 1 or 2 or 3 decades. Then that soil will be at max capacity and it won't be effective anymore. So nature-based solutions will be a part of a cocktail of solutions that could get us to net zero. But for the long sustained run, I think we might also need to use other technologies as well.
It's a any threat of disease within the permafrost and not the melting out of that purely to the side.
No, it's both. I think so. I think the threat of like unknown zombie viruses that are unknown to science is the risk is there, but it's probably a very, very small risk. But there is, for instance, we know, and it's already occurred, that there are cases where, for instance, anthrax can be spread because there are. It's usually from reindeer that died. So anthrax was quite prevalent in the Arctic about 100 years ago, and then you had reindeer that would die from anthrax, and then they would do mass graves of reindeer in the Russian tundra. And now these are thawing out, and then the anthrax has survived, and then it's coming out again. So there are cases of that happening, and it's actually in the middle of Yakutsk, which is a big city with 300,000 inhabitants. There are anthrax reindeer graves in the city, but still in permafrost. And then there's also contaminants, organic pollutants buried in permafrost. Mercury is a prominent example, and very large amount of the global store of mercury is actually in permafrost. And that can be and most of the sources for that is actually natural, just that it's accumulated over thousands of years. And then if you have like a pulse thaw event, you could get like 100 years of mercury being released very rapidly into a stream or lake, which would actually give you the spikes of the toxic version of mercury, metal mercury, that could bioaccumulate in fish and be a concern also for populations.
I would add just to keep the doomsday scenario going. Often the wastewater treatment facilities in the communities, if they have them, are insulated by permafrost. Like something keeping the lagoons, the treatment lagoons intact, and so if those wildlife do get moved, there's still
You also get a lot of threats to a lot of the permafrost communities would also have their freshwater source would usually depend on the permafrost environment remaining intact. So it's like a lake or something, and then so there's been examples also very nice freshwater lakes that were on permafrost, and then the permafrost thaw on the whole lake that drains away, and all of a sudden there's no good freshwater for community living. That's been there for a long time.
Thank you.